Okay, it's 4 o'clock, so we can begin. Welcome to COP 3402, System Software. My name is Brent. I'll be your instructor for this semester. And I'm going to make you a promise at the beginning of this course that I made last semester when I taught this course. In this course, you will actually learn skills that will be very useful for you as a programmer. I know a lot of courses you take at university, sometimes you don't see the direct impact or applicability of those courses and the material in them. But I'm going to promise you that in this course you will learn at least one thing that will be very beneficial to you for the rest of your career as a software developer or programmer or anything you do relating to tech. Especially if you're a sysadmin, you'll learn a lot of things that will be useful for you. So with that preface complete, let's begin with the course. So again, my name is Brent. I'm a PhD student here at UCF. My advisor is Dr. Paul Gazzillo. He is the one who designed this whole course. I've made some slight modifications to it as I've been teaching it. But I first taught it last semester, and before that I was the TA for this course for a year. So I know the material fairly well. Also, I use a lot of material in this course almost daily for my research work at UCF under Dr. Gazzillo. My areas of research are sort of the intersection of the three listed here: SE, software engineering, PL, programming languages, and security. These days it's not so much about programming languages, but more about software engineering and security. And my website is listed here, so if you want to learn more about me, I have a whole web page. And if you want to if you like reading, I should say, I have a list here of a ton of books that I've read that I consider some of my favorites. So if you want to talk about literature or books afterward, if you like reading, please come and speak with me. I would be happy to sort of geek out about books with you. So, okay. So the first question I think we should probably answer here before continuing is why? Why even study system software, and maybe what is it? So the question I want to ask you is, is anyone familiar with Isaac Newton? Probably, right? Can anybody tell me one thing that he did or is supposed to have done? Calculus, right? So he was a polymath, very skilled at math, also decently skilled at illustrations. One thing that Isaac Newton actually did, which I want to hope instills a value in all of you throughout this course, is that he took copious notes. So you can see this image here. It's a little small. Maybe I can make it bigger. Maybe not. This is a picture of Newton's actual journal for how he took notes and how to create lenses for astronomy. So Newton, he was into astronomy. He used these big telescopes. In his time, you couldn't just buy a lens for a telescope on Amazon. You had to, in his case, make it yourself. So he actually took extensive notes on how to grind his own lenses to make his own telescope lenses for his own astronomy work. And I hope that throughout this course, that will kind of be instilled as value in you all, and that you can grind your own lenses, so to speak. You can make your own tools. And especially with system software, this is the case, and especially with programming. I think there's a quote from Fred Brooks. I don't know if anyone's heard of the Mythical Man Month. It's a very popular book about software development. In that book, Fred Brooks says, the programmer is like the poet in that we have the ability to create things out of pure thought stuff. Very few other engineering trades have that fortune of being able to do that. You look at mechanical engineering, other kinds of engineering, they have to use actual physical materials. We don't have to do that. We can actually build things directly, just converting our thoughts into code, and then have it mechanized right in front of us and working. So the idea here is just to learn your tools well and be able to make your own tools if you need to. And this quote here is just an old proverb, is that a poor workman blames his tools. And again, because we are programmers, we have the great fortune of being able to modify our tools or make our own tools if the tools that are given to us do not suit our purposes. And a quote that Dr. Gazzillo originally thought was his own was that tools are made for man, not for tools, but actually Aldous Huxley and Thomas Merton beat him to it and actually said this before he did. So the idea here is that you shouldn't feel constricted by whatever tools are given to you, and don't blame them either. Again, if you find that the tools you're using are not suited to your task, you can make your own or modify the tools that you're using as you see fit. Especially with open source software, it's pretty, I wouldn't say easy, but it's accessible to do that. And then, this is actually Dr. Gazzillo's father, not mine. But I'm sure everybody has some older relative that has told them this at one point, something to this effect of maybe not don't use your bare hands, use a tool, but maybe something more along the lines of work smart, not hard. I'm sure many of us have heard that phrase before. I would argue that you should work hard and smart, and often you don't actually recognize what working smart is until you've worked hard to begin with and identify the patterns that you need to actually exploit in order to work smart. But this, I guess the message here still stands. If you have a good tool available to you to solve a problem, you should use it. You shouldn't try to muscle your way through a problem suboptimally. So sort of the why out of the way, so why you should learn system software to be a better programmer. There's sort of the what here now, I guess, with the course goals. Number one, learn to use and create system software. So what exactly is system software before we continue? So the way we're going to be defining system software for this course is as the bridge between the kernel and user applications. So if you look at this whole diagram here, where we have user applications at the top, this includes things like video editing technology or web browsers or video games, email applications. And at the bottom we have hardware, which is literally the actual motherboard, hard disk, CPU fans, etc. that you have on your devices. Then system software sits somewhere in between those two layers. Specifically, it sits above the kernel. So the kernel is sort of the software that is used to interact directly with hardware in your machine. We're going to learn more about the kernel throughout this course. Well, more about how to interact with the kernel throughout this course. But system software is between the kernel and applications. The reason for this is because as a programmer, we don't want to have to interact with the kernel directly. It's pretty low level, lower level than C code. And C is not that low level, but maybe you understand what I'm meaning. Things like Python would actually be almost like above the kernel, above system software in this illustration here. So it makes it easier for programmers to actually program against hardware by having this sort of interface between the kernel and user applications. That's what system software sort of fits the role of. And I know this is really abstract, so to give you some examples to help clarify what I mean, we have libraries, so like standard I/O, that's a C library. You probably all use it for printing output to files or to standard out. That would be an example of system software. Mallec's not a library, but it's a library call. So that's something that, again, would be an example of system software. Programming tool chains, so GCC. Can anyone tell me what GCC stands for? Has anyone used GCC before? I'm sure many of you have. Can anyone tell me what it stands for? Close. It's the GNU compiler collection, because it's not just a compiler, it's the whole compiler tool chain. But very close. Linkers, which are part of that compiler tool chain. These are also tools that developers will be using. And programming environments, so version control with Git. Has anyone here used Git before? Can you raise your hand? Okay, that's good. Has anyone here used GitHub before? All right. So, next question. Has anyone here used Make before? Okay, fewer hands raised. That's pretty typical. As you can see, the trend here with system software is that it's often developer-facing tools, not something that end users will be interacting with directly. But they make our lives as programmers easier. And we're going to be learning how to use Git and Make and how to actually implement a compiler throughout this course. So course goal number 1, using system software. And we're going to be learning how to use the command line. Specifically, we're going to be learning how to use the born again shell, bash. That's what bash stands for. We're also learning how to use Git. So for version control, like I mentioned earlier, all of the projects in this course and exercises you will be submitting using Git. So if you don't know Git, if you don't know how to use the command line, you're going to be kind of thrown into the fire. No, you're not going to be thrown into the fire. We're going to have you gradually learn how to use Git and upload all your files for your projects to a remote server that UCF owns. So it's going to be kind of cool because you can go through this whole process. It's going to be similar to what you would do in actual software development, where you're modifying files, making changes, committing those changes, and then uploading them to a remote server. And then we have automated grading scripts that will grade all the project files that you upload. We'll be learning more about file systems. So I've heard this from some people before, and I don't know if I believe it, but I've heard that a lot of people in I guess high school and below actually don't know what a file is. They're so used to using iOS applications that they're just used to apps, and they actually don't know what a file is. So I don't know if I totally believe that or not. I feel like that's really just a minority of people that are getting picked on that don't have this knowledge. What I'm more inclined to believe is that many people don't actually think they know what a file is, but their understanding is somewhat incorrect. So a file is not just a file path. A file is not just an icon on your desktop. A file is actually a blob of contiguous data. And we're going to get into this more later about how files are actually stored in your machine, how different links to a file are not the file itself, how files form a directory hierarchy. You can see this illustration here, where they form a tree structure. We'll be going over all that more in this semester and navigating file trees in the command line. Actually, we'll be doing that later in this very lecture, because I'll explain why later, but the lectures are kind of compressed. I've merged 2 lectures into one day sometimes because we have a shorter semester this semester rather than fall and spring. So we are going to learn how to use the GNU and Linux development tool chains. So these are, I would say, time-tested tool chains that people have been using for decades now to develop software. So especially the GNU set of software development tools and Linux. If you don't have a Linux machine, that's okay. You are going to be logging on to Eustace, and you can use the remote servers to do your development that way. And it's not a requirement, but I would strongly encourage you all, and you might not like what I'm going to say, but I would strongly encourage you all to learn how to use Vim or Emacs. I prefer Vim, but if you want to be more academic, you can use Emacs. I don't know. You'll see me using Vim throughout this entire semester, so yeah. Okay, course goal number 2 is to actually build system software. So we're actually going to be learning how to use or invoke system calls and library calls from within C code to develop our own set of system software tools. And this is what the project's going to be about. So for example, we're going to go over how to use command line tools that already exist to navigate file trees and print out the contents of file trees. But we're also going to be writing our own C programs that can do that for us as well. The goal here is just to learn how to interact with the kernel at a lower level and create our own set of system software tools. Yeah, we'll learn process management, what exactly a process is. It's a running program that will be drilled into you throughout this semester. The difference between, a program that's not running and a program that is running, the different states a program can be in once it's running, and changing I/O without changing the source code of a program directly. There's ways to do this that we'll see later in the semester. Compilers, so working with language processors, there's interpreters and there's compilers. There are different ways to implement a programming language. We'll be looking at both of them. Specifically, in the second half of this course, we'll be focusing on compilers and how to create one. So we'll provide you with some code to get you started on writing the compiler, but the back half of the compiler, the part that actually does the translation from code that you write to the code the computer understands, will be pretty much all you. You'll be writing that compiler. We'll give you a lot of help, but I think it's one of the most fun parts of this course, writing the compiler. So yeah, the first half of this course is going to be more about these 2 slides here, file handling and process management, and then creating our own system software. The second half of the course is going to be about creating a compiler. It used to be, back when I took this course with Dr. Gazillo, when I was an undergrad, 7 years ago, we only wrote a compiler. That was the whole course. Dr. Gazillo had written a compiler one winter break, and then he gave us basically all the C code. He carved out the function definitions and told us what to do, and that was it for the whole course. Many students struggled because he assumed you had prior knowledge of how to use Git, how to use make, how to use the Linux command line, and a lot of people didn't know how to do that. So he restructured the whole course to spend the first half just teaching everyone all of this. So the second half of the course, we can kind of hit the ground running with working on making our own compiler. And the ulterior educational motive here that Dr. Gazillo and I both share is to make you a better programmer, because there are many things that can make you a faster and more efficient and more correct programmer, I would say, that I think are easy to just become unaware of or be unaware of and never learn along your career as a programmer. Now, I guess to exemplify this, some of these ideas and practices, I'm going to use the story of the tortoise and the hare. I don't know, is anyone not familiar with this story? I feel like everyone in Western society, maybe around the whole world, should know the story. Okay, so I'll begin. So the tortoise and the hare are both given a challenging programming project, probably one of the projects that we're going to give you during the semester. Some of them will be pretty challenging, especially in the first half when we're all writing just C code with no real starter code given. The hare immediately starts programming. They like coding. They just start busting out lines of code immediately. The tortoise does not start programming right away. The tortoise starts writing comments, planning, and tests. This is a big thing. They write tests before even writing a single line of code. So they have this idea of what they want to accomplish, and they kind of work backwards. So before the tortoise even starts writing code, the tortoise is busy writing tests and comments and all this boring stuff. The hare has already finished writing the code. But this is where the real challenge begins. The hare starts to run a large test given by the professor, and of course it does not work. So now their program is not working, and they have to go back and fix things. And because they didn't write any comments, all their code was kind of just hacked together in one caffeine-fueled morning. They just start changing things willy-nilly and don't actually fix the problem. And then, in fact, they introduce more bugs, perhaps. But eventually, they break another test, and then fixing the bug in the next test breaks the first test, and now they have no clue what's going on, and they're just stuck thrashing on this code base trying to fix it. Yeah, and if they get lucky, maybe they can get the correct sequence of lines of code in their file to actually pass all the test cases. Maybe. But in the end, they still get a bad grade because the hare is not given all the test cases up front. And this is actually the case for all of you. We're only ever going to give you half the test cases. We're going to give you the odd number of test cases for you to test your code against. The even number of test cases that we're going to have are going to be private. You will not be able to see them. So make sure to write your own tests, because the other cool thing is, though, we are going to give you brief English descriptions of what the hidden tests are testing for. So you should be more like the hare, or the tortoise I should say in this case, and write your own tests for the hidden test cases. And you can do this pretty easily because we're giving you the public test cases, the odd number test cases. You can literally just copy and paste those and use that framework to develop your own tests for the hidden test cases. That way you can ensure before submitting your code that it completely works. So the tortoise, meanwhile, hasn't written anything yet. They've been dividing the problem down into smaller pieces, so divide and conquer. This is a classic like CS2 algorithm you've learned, probably CS1 as well. So they write some small examples, simple examples for each part of the problem. And then they take an easy piece of the problem and write some comments about what the code should do. So again, working backwards, not immediately writing the code. And then finally, the tortoise actually starts writing code to solve that small part of the problem, little by little, piece by piece. And if small things don't work, the tortoise immediately solves those problems before proceeding. And the tortoise actually assumes, they program defensively, assuming that things are not going to work. If they just code without thinking. They have to actually put a lot of effort into making sure that everything works. And the tortoise knows that debugging is going to be very difficult, especially when parts of the code start interacting with each other. But in the end, so the tortoise took a lot longer, but in the end, the code is easier to write, probably easier to read, I would guess as well, since it's so well commented and intentionally written, and it works correctly. So I think one thing I want to get across here, convey, is that true speed is not the number of words per minute you can type. True speed is how quickly or deliberately and steadily you can work without making mistakes, or if you're making mistakes, having all the infrastructure in place to correct those mistakes rapidly. That's where true speed actually comes from, not from being able to type really fast and produce a bunch of code that doesn't actually work. Yep, and if they encounter any errors, because their code is well written and they've figured out the different parts, laid out the different parameters of the problem for themselves, they're able to isolate parts of the code that does not work, they do not work, and they can actually fix those small parts with individualized test cases. Yeah, so well commented, simple, organized. Yeah. So I guess one fun tidbit here, sort of in the spirit of this, the Linux kernel has style guidelines for writing code in the Linux kernel. And one of these guidelines is that you have to use tabs, and the tabs have to be 8 spaces wide. That sounds pretty big, right? I don't know, most of you probably use like 4 spaces. Can anyone tell me the reason for having this restriction? Anyone guess?
8 bytes or 8 bits?
No.
Bytes, I mean?
No. So there is that connection, yeah, but no. Yeah.
To avoid nesting?
To avoid nesting, exactly. If your tabs are 8 spaces wide, you can't really have a lot of nesting in your code before it goes like far off your screen. So the reason that they have this restriction is for this purpose right here, to keep your code as simple as it can be and to avoid a lot of complex nesting of different conditions and statements and whatnot. So this is something that people actually use in practice. Like good programmers follow this principle in practice. And yeah, the moral of the story, be the tortoise, don't be the hare. So the ways to do this, you should know your tool well. Again, know your tools. You shouldn't be writing tests to test how C works or how bash works if you're going to be writing bash code at all. You should be able to understand how your tool works. You don't have to actually test basic functionality inherent to the language. That, again, slows you down. So know your environment well, know your tools well again, develop really fast workflows. I'm going to show you some workflows throughout this course that are pretty fast, where you don't have to even leave your editor to build all your code and run it immediately. Those kinds of tricks will greatly speed you up. Also knowing shortcuts in the command line, knowing shortcuts in your editor, all these things will help accelerate you while writing code and testing code and running code, etc., development in general. And it's a good idea to break problems down and use abstractions, like, for example, functions, to organize your code into pieces. This not only makes it easier to read and easier to write, but also easier to debug in case you encounter problems. So again, like the tortoise, make sure the simple stuff works before moving on. You don't want your foundation of code to actually be invalid before you continue iterating on it. And write your own tests and save them. So a common trap for novice programmers is to have no tests. And I guess one level above that is to have a single test file that you're constantly manipulating and making changes to and then using for testing all your code. Don't do that either. Have separate tests for each scenario you want to test, and then just write a script to run all the tests. It's way more robust to test your code that way. Don't be going from the command line and just manually testing things one by one, because every time you manually perform some action, it imposes a burden, a tax on your time and effort and mental energy, really. So you should try to automate this as much as possible. Automate every step of this process as much as you can. And develop good debugging skills. So sort of in lieu of this, actually, let me go back. Okay, so that just links to not what I thought it did, but that links to later in the slides. Okay, so I guess now a quote here to sort of wrap up this video on debugging from Brian Kernighan. Does anyone know who Brian Kernighan is? Really, I'm shocked. No one recognizes the name. Did any of you read the C programming language book? Have you seen it? Darn, okay. Have you all taken Intro to C? I assume that's a prerequisite for this course, right? All right, so the required textbook for that course, at least when I took it, was the C programming language. Brian Kernighan is one of the authors of the C programming language book. He's not one of the authors of C, but he is one of the authors of that book and kind of helped create standards for how you should write C code. He's a very famous programmer. He's also a professor. I forget at what university now. But he's written several books on programming. And he says, this is sort of like a jokey quote, sort of like tongue-in-cheek, but he says, everyone knows that debugging is twice as hard as writing a program in the first place. So if you're as clever as you can be when you write it, how will you ever debug it? So, I don't know, hopefully the idea gets across here. If you were going as hard as you can writing your code, then you're never going to be able to debug it because debugging is even harder. And I think I want to, before going on to what's a bug, I want to illustrate one more concept here about following a specification. I think this is the right place in the slides to do this. What I mean by breaking a problem down into pieces and why it's so important to do that is, look, for example, if we have this illustration here, this little stick figure that's T-posing as you, and you're writing code, you're following some specification. This could be a homework assignment description. And you're translating this into code, an implementation. If you just take all the code at once, all the specification at once, and try to translate it all into code at once, this is what the hare would do. What you end up is a situation like this, where if the blue is like your code, you're covering the whole implementation. You've implemented all this code. But then what happens is, because all code has bugs, it's almost inevitable that code is going to have bugs. Because you wrote all the code at once, the bugs in your code are going to be all over the place. And so now your search space for finding these bugs is the whole specification, essentially, your whole implementation, all your code. That's a big headache, and it's a lot more effort for you to debug. On the other hand, what the tortoise does, the tortoise did in the example earlier, is break the spec down into pieces. So in this case, let me finish drawing these lines. Now when you would go to implement your code, your specification to convert this into code, you implement one section of the spec at a time. And the reason why this is so beneficial is because now, even though this takes more effort because you have to spend extra time and energy slicing up the spec into different segments, now if there are bugs, they're localized to those specific sections of the code. And ideally, you're writing these segments one at a time, so as bugs appear, you'll be aware of that immediately and can immediately fix them. And because you divided the code up into different segments, you can write test cases targeting each of these different parts of the implementation. So there's many benefits to writing code like this in this gradual segmented process rather than just throwing everything at the wall at once. So any questions so far? Okay. So now I want to continue by asking, what is a bug? So can anyone tell me what, in their words, what a bug is?
When a program is doing something it's not intended to.
Not intended to? Okay. I think maybe you had an answer, or is it the same thing? Okay. So that's kind of halfway to what I was thinking. It's not that a program does something wrong, which I'm not sure exactly is what you had said. The way we're defining a bug in this course, the way that we're going to define a bug, is that a program does something you don't expect, which might be what you didn't intend for it to do. So there is a difference here. The difference is that we're actually defining, I guess, a baseline against which wrong is. It's just not what we expect the program to do. Because the program is doing exactly what you told it to do. It's just not what you expected that it would do. So actually, I think I just did this in reverse, this illustration. This debugging schema here is sort of what I just illustrated. You would narrow down the problem into sections and then implement each of those parts of the solution one at a time. And we're going to develop debugging skills throughout this course. I won't be teaching you all how to use a debugger, but there will be cases in which using a debugger like GDB will be useful. And this is good because you'll actually get to see how your program affects memory concretely rather than you just guessing what the program is doing while it's running. And if you do run into big problems that you can't actually solve yourself, come to my office hours. I'll be able to help you there. And I'll show you after this lecture, after these slides, where that will be. So actually, this is where I was supposed to draw the diagram. I drew it too early, but oh well. I think the point still stands. Yeah, so there's, let's see, a document here, an article. A lot of these articles written by older programmers are usually pretty good, so I recommend checking this out. Stepwise refinement. Let me see if I can go back to where I was. So these slides are actually generated off the course notes. So Dr. Zillow set this up, this whole system with Emacs and whatnot. So the slides you see here, they're not available online, but all the same material and more is on the course website. So these are literally just generated off the course notes. So you have the same exact content and more. The slide notes are not shown here, but they'll be shown on the website as well if you want to see all the stuff that we go over in lecture. Okay. And now, I guess something kind of funny, the 3 virtues of a great programmer. This is funny, but also somewhat serious. Let's see here, okay? So according to Larry Wall, the original author of the Perl programming language, fun fact about Perl, if you look at Perl source code, there are quotes from Lord of the Rings at the top of many of the files in the comments. I don't really know why they did that, but I've noticed it before going through the code. There are three virtues of a great programmer, three great virtues of a programmer: laziness, impatience, and hubris. So laziness, the quality that makes you go to great effort to reduce overall energy expenditure. It makes you write labor-saving programs that other people will find useful and document what you wrote so that you don't have to answer so many questions about it. Okay, can't zoom in that much. Okay. Impatience, the anger you feel when the computer is being lazy. This makes you write programs that don't just react to your needs, but actually anticipate them, or at least pretend to. And we'll see examples of what that anticipation looks like later in this lecture. And then hubris. Does anyone know what hubris is? Yeah?
Like overconfidence and arrogance.
Yeah, so like I said, I like to read. Hubris is something that comes up a lot often in like Greek mythology. It's excessive pride, that, especially against the gods, that leads to you getting smited. So I don't know if this was the correct word here. Maybe I would just pick pride or arrogance. This is the quality that makes you write and maintain programs that other people don't want to say bad things about. This includes writing good documentation, because you don't want people to say like, oh, they don't know how to write documentation, they don't know how to write code, their code is buggy. You want to be able to write really good codes so that other people have no grounds to criticize you. Okay, let me zoom out. Okay, so I didn't update this, but you can go through the webpage here and see all the differences in from prior iterations. This is going to be mostly the same as last semester. I'm changing some of the notes, and I might change some of the assignments a little bit, but I think for the most part, this course is going to be mostly the same as last semester. The biggest difference is that in the spring, because we had more lecture days, I was able to divide up the content more evenly. Because we have fewer lecture days, but the lecture days are longer, I've actually combined some lectures into a single day. So today we're going to be going over lectures 1 and 2. What that also means is that some of the homework assignments will be assigned in pairs. So today you have homework 1 and 2 due before the next lecture. Whereas in the spring and fall, if you were to take this course, it would be 1 lecture each day, 1 homework assignment each day. But the homework assignments are pretty short, yeah?
Are the lectures going to be posted online?
Yes, I record all lectures. I'm recording this one right now, you can see. And I'm going to post it online. So if you like the class lectures and want to be able to see student questions, and you'd like the pace that I'm going at here, I'm a little bit slower, I guess, not as compressed, then I would recommend watching the lectures that I record this semester. If you'd rather see a tighter lecture where I just go over the material and there's no student questions, many of the lectures from last semester I recorded separately from actually giving the lecture. So if you go online and look at my YouTube channel, which you'll have links to in the course website, you can find the playlist for last semester's lectures, and you can actually view lectures that have no students, I'm not at the board, it's just me talking and going over the concepts for each lecture. And they're shorter, but you lose some of those questions that students ask. I also don't go over the homework in those lecture recordings. In the ones I'll be doing in this semester, I'll be going over the homework in the recordings as well. So there's pros and cons to the different recordings. And now let's go over the syllabus. So I'm actually going to go to the syllabus page here. Has anyone seen the syllabus yet? Raise your hand if you've seen the syllabus page. Okay, so most of you have. Any questions before I continue? No? Oh, yeah?
Couldn't find the notes on Canvas.
Can you find the notes on Canvas?
I couldn't find the notes.
Oh, they're not on Canvas, no. They're on this website here, which I think I have a link to on the course page. I think in the syllabus there's a link to this website. And I think, if I haven't, I'll check Canvas after this. But I'm going to update the Canvas homepage for this course to just link directly to this site. So if I haven't done that already, I'll check that and try and fix it. But we don't use Canvas for the course notes. The reason is that this is just way faster, like way more responsive. You can just click and immediately it takes you straight to the notes. And also, again, we have this whole system set up where we generate the slides based off the notes. It's very useful. And also, as I think this last semester showed, Instructure is not the most secure company. I don't know if... Is anyone not aware of what happened at the end of last semester? Yeah, so I think you're all aware. I got hacked. It was pretty bad. Really bad for me because I had actually waited until the day before the grades were due in my UCF to upload all grades because I wanted to give students as much time as possible to reach out to me with questions. And by doing that, I almost put myself in a pickle because Instructure got hacked right before the grades were due and I couldn't import my grades from web courses. So thankfully, the following morning I was able to upload it, but I had to quickly write a script to convert the export format from web courses into the import format for my UCF. I was able to do it. It worked. There are cases in which you should be the hare. you should write code fast. No, I went pretty cautiously there because I was dealing with student grades. But yeah, that's another reason why maybe you should prefer custom built solutions over cloud solutions sometimes. Anyway, so course details, we're going at a pretty good pace, so I feel like I can go off into these tangents sometimes. So the course details, yeah. Lectures will be held in this room, 4 to 5:50 p.m. I'm a morning person, but I chose this lecture time because the other alternative for this semester, I think, was like 8 a.m. And while I would love that, I don't think most of you would like that. So I decided to choose the much later in the day hours for the semester instead. Yeah, held here. The final will be on July 29th. So I think UCF final exam schedule. You can always check this page to see this. I had several students last semester who thought the final was going to be at our regular class time and came to class 2 hours or at the very end of the final exam instead of when the final exam started last semester. So be aware that our start time for the final is, actually I guess it is at the regular class time this semester. Let me check. Well, I guess we can check right here. So we're meeting Monday, Wednesday. The class start time is at 4 p.m. and it goes on until 5:50 p.m. Yeah, so 6:50 p.m. So I guess it will be the same, or wait, that's not. This is spring. There's no option for summer. I think I saw this earlier, and I think what I ended up doing was just choosing a regular class date and time to schedule the final exam because UCF didn't provide me with one. So this semester, yeah, if this is correct, which it should be because I checked all this already, July 29th will be our final exam. It'll be in this class at the regular time, unlike last semester, which was a different time. It'll be the regular time. So 4 to 5:50 p.m. I'm not going to give you the whole, 3 hours. I'll give you, I guess, 150 minutes. That should be enough for the final. I write the final and the midterm custom for each semester. And I go over the questions afterward too and release all the answers to you all after the exam's over. So I make a custom exam for each semester. So I have a whole system set up to make it pretty fast to do that. So yeah. The TA for this semester is Taiwo. I recently met Taiwo. Taiwo is not somebody that I normally work with, but he was assigned to me and he seems like he's pretty competent. So I recommend going to his labs for reinforcement of the course material. His lab times will be here. And the labs or for review of course material. If you have questions, you can ask them during the labs. And Taiwo, I'm giving him permission to go over small snippets of the project or some general ideas of the project. He won't be giving you the solutions or anything. I actually did that in my first semester and I got in trouble for it. But he'll be giving you like small snippets of some of the projects and he'll go over the homework with you and go over any other questions that you have. There's also 2 other graders we have for this semester, 2 undergraduates that work with me on my research. So I'll talk more about that later, but one of them will be in charge of homework, the other one's in charge of grading the project submissions, and I'll talk more about why that's important to you later in this page. So the course schedule is here. All these topic pages are already available. You can access them all and see them all right away. The homework is locked right now. But if you really want to see it, because I'm probably not going to change it, maybe I will, probably not, you can actually go to the directory page here, go to spring 2026 and see the whole copy of the course for last semester, and all the homework is available here as well. And the assignment descriptions, they're all available here as well if you wanted to get ahead starting a preview of what's going to be assigned to you. But I mean, the homework assignments are not extremely difficult. In fact, we only grade them basically for completion. Well, effort. You can't just submit nothing. You have to submit a genuine attempt at completing the assignment. And we'll give you points for that. So I'd recommend just not preempting too much. Just go at the pace of the course. They're not really that hard. Yeah. And they're locked on web courses anyway, so you can't even submit them until the day they actually open up. So you can see right here, like this one's locked for now. Homework 1 and 2, meanwhile, They're already published. They're available. You can start them after this class. Homework is due at the very minute of the next class. So homework 1 and 2 will be due at 4 p.m. on next Monday. So try to submit everything before then. In addition to homework, so homework is only worth 1 point. Maybe I should scroll down here and show you this breakdown now. Dr. Gizlo and I structure our courses so that all the points add up to 100 exactly. So if you want to get your score, you can just add up the points for your course that you have in your own grade right now. There's also some extra credit opportunities. I'll be talking about them later. But the base points of the class add up to 100. So yeah, there's 24 homework assignments. Only 20 of them count. The other 4 are dropped. So if you miss 4 homework assignments, they're not going to count against you. You get the same score as somebody who completed all 24. But I recommend doing them because they help you reinforce the course material. So there's 2 exercises. These are going to be the VC exercise and the into post exercise here. These are each due within 1 week of being assigned, so they're due pretty quickly after they're assigned. Exercises are short programming assignments that review pretty fundamental material for the course. So that's why we assign their deadlines to be so soon. And they also have a much tighter deadline for regrade requests, which I'll get into later. So projects are what comprise or constitute the bulk of the course's points. You can see 48 points come from projects alone. I did have students last semester who neglected to do most of the projects, but did well in the exams, but still failed the course. So please do the projects. Do them promptly, and don't neglect them. The first project is going to be assigned next Monday, the Hello project. And again, because of the way the course is structured with having fewer days but longer days, I'm assigning both the exercise and the project in the same day. So I recommend working on them as soon as they're assigned. These are not very difficult projects, these first 2. They're pretty easy, I think, straightforward. The hardest part will be just learning how to use the command line. So the cool thing with this course is that because most of the points come from projects, and because we want to reward you for doing well rather than penalize you for not doing so well, you are allowed to submit and resubmit project submissions until, almost the very last day of the course, August 3rd. So because we're uploading all the projects with Git, you can easily make changes to your code and re-upload it to the servers we have. And we allow you to do that until August 3rd, basically. And if you do that, if the normal deadline passes and you make changes to fix some failing test cases and upload your modified code, corrected code, we'll give you only a single point penalty. And this applies to every single submission after the deadline. Only a single point penalty out of 8 possible points. And because some projects have extra credit opportunities, if you implement the bonus features, you'll have enough extra credit to offset that negative 1 point penalty and still get over 100% of the project, even though you submitted it perhaps weeks or even months later than the normal deadline. So I recommend doing this early. And just to be very clear, this deadline, this final end of the semester deadline, is for requests for regrade, not for submitting your updated code. So I had some confusion about that last semester. So if you upload some changed code with corrections, you have to make the request to have that regraded before August 3rd. Do not wait until August 4th to request a regrade to a submitted project and then assume that we're going to regrade it for you. We will not be regrading any projects after August 3rd. So make sure all your requests for regrades for late submissions or for more points for test cases that you previously failed, that you have all those requests in by August 3rd. And I'll be making an announcement about the contact info for the TA responsible for this. I think actually she's here, right here. So this is one of the undergraduates who's one of the graders for this course, Rasman. Send your regrade requests to her. So again, the procedure is if you have some changes you want to make to one of your code submission files or project submissions, make the changes, upload them. We'll show you how to do that later in this course. And then send an email to Rasman requesting her to regrade your project submission. You have to always email when you want to regrade. You can't just upload and expect us to do the regrade for you. We have no way of knowing, or we do, I guess, but we're not going to check Git every single day, the GitOlite server to every single day to see if anybody has uploaded new code to be regraded. You have to make a request explicitly to Rasman. And make sure all requests are made by August 3rd at the latest. Yeah?
The third communication for you and TAs is email, not web courses?
Either is fine. Yeah, you can use web courses as well. I'm going to tell Rasmus to check web courses as well. But yeah, I check either. I check them almost compulsively. So yeah. Don't expect me to reply after 5 p.m., but I probably will. So yeah. And weekends. But I like it though, so it's fine. Okay. Let's see, any more important points here? Yeah, midterm and final are here. The way they work is you're going to come to class with your laptop, and you're all going to take the final exam just on web courses in class. There's no lockdown browser, none of that. If you don't have a laptop, I'll be printing out physical copies of the exams as well, but I'm not going to print out enough for the whole class, just a few for people who don't have laptops. You can also rent laptops from LibTech from UCF's library to use for the exam. Other students have done that before. We give you 8 pages of double-sided notes, 8 double-sided pages of notes for the midterm and 12 for the final. So you have copious notes available to you. Please take advantage of that. Don't cheat. I have had students cheat before. They've gotten caught. We're going to have proctors walking around monitoring your screens to make sure you're not cheating throughout the exam. There's no external digital tools allowed in the exam. When you're taking the exam, you only have the web page open and that's it. And it's going to be pretty easy to spot cheaters in such a small room. That's, I guess, the one benefit of having this room. So please don't cheat. Oh yeah, one more important thing. Attendance is mandatory and it's graded. I'm not taking attendance today because it's the very first day and I don't know if everyone's aware of this fact yet, but I do grade attendance and make it required. So if you don't show up to class, well, if you do show up to class, it's worth 4 percentage points of your grade. So 4 points out of 100, 4 percentage points. And if you show up to at least 75% of lectures for the semester, so that's 3 out of 4 points that you've earned for attendance at the end of the semester. I have a script that checks all of this. I give you 2 extra credit points at the end. So you're rewarded again if you are diligent and actually show up to class. So yeah, you don't need a perfect score in attendance to get the extra 2 bonus points. You could attend 75%, get 3 out of 4 points, and then you get the 2 extra bonus points, you get a 5 out of 4 on attendance. And yeah, here's the grading schema. No minuses, just neutral and pluses. Breakdown of where everything's available. I'm actually going to remove Ed. I'm not going to use it this semester. Nobody really used it last semester. It's a forum for posting questions for courses. I'm not going to use it this semester. You'll all need a laptop. Again, you can rent the ones from LibTech if you don't have one. But many laptops, you can get laptops that are pretty cheap these days if you don't have one already, like $100 or less in some cases. Yeah? How am I checking attendance? I use UCF here. So UCF here, if you're not aware, has anyone not used that before? Could you raise your hand if you haven't used it before? All right, so I see one person, maybe some others don't want to raise their hand. Basically, it's a alternating QR code. It's a QR code that's constantly shifting, and you have to scan it with your phone, and then it automatically marks you as here when you do that. I'll also be bringing a physical attendance sheet for students whose phones don't work or who forget a phone. Please don't just walk in, sign the attendance sheet, and walk out. I was pretty lax with that last semester, but I think I'm not going to be this semester. If you do that, I'm going to probably just cross your name off. I'll literally just walk up to the attendance sheet and cross your name off before you leave if you are just going to walk out. So please actually try to attend the whole lecture. Or at least the majority of the lecture. So we'll be logging into Eustace for the course for uploading our assignments. There are ways to make this less painful instead of typing in your whole NID and password every time. I'll go over that briefly. I think some of the notes in here show you how to do that. There's a bunch of different guides on here. Links to how to use like Linux, or let me see, how to set up Eustace for Linux, Mac, Windows. Oh yeah, the textbooks. So these are important. I haven't fully read these books, but in the parts that I have read when I was a TA for this course, I was reading parts of them. It's actually pretty well written and pretty, I'd say, entertaining to read. I like programming, so of course I'll say it's entertaining. Don't download the whole book. This actually, I believe it locks the book for all students, so we have like a 1 license for the whole class. Instead, just download individual chapters. So, yeah, and don't read online either. That also locks the book for other classmates to use. Don't read online, don't download the book. just select download PDF chapters and download individual chapters that you want to read, which the readings will be listed on the schedule page up here, what sections of the books to read, or the different books to read. So, yeah. For these 2 books, just make sure to download individual chapters. Don't download the whole book. Don't select the read online option. Just biggest thing is don't use read online, because that locks it for everyone else, and they can't use it. Yeah, a bunch of other books. There's like an illustration here showing you exactly what to use. Some other books to read. This is like the classic book, the Dragon book. I won't go over this. Yeah, again, I recommend using Vim or Emacs. The reason why is because these are command line tools, and the whole point of this course is, one of the points of this course is learn how to use system software and in the command line. Learning how to use Vim or Emacs will help reinforce this for you. I especially prefer Vim because Vim lets you interact with other command line tools without leaving your editor, which kind of is more in the spirit of, again, using the command line and learning the command line is like a sea of applications, rather than using Emacs, which is like a monolithic application. And of course, rather than using VS Code, which is like cool, but it has like a big performance penalty. It's really slow, I'd say, and it's an Electron app, so it's energy hungry. And if you use VS Code if you try to use VS Code for the projects, you're quickly going to run into disk quota issues on Eustace, because VS Code creates these hidden directories. I don't know exactly what they're for, on whatever server you use to remotely log into with VS Code, and then you'll end up with a disk quota exceeded error pretty rapidly. Many students have faced this issue before, so just letting you all know. Yeah?
You get the same thing as you're describing if you work in C-Line?
I don't know. I haven't used C-Line. Yeah. But if you really don't want to use Vim or Emacs, you could write all your code in VS Code locally and then push it to the remote repo and test it there. But that's going to be really painful as well because you have to constantly go back and forth. So I don't know. The easiest thing is probably set up a virtual machine with Linux installed, or a virtual machine for Linux, and just run all your tests locally that way. That way you don't have to always have an internet connection to Eustace, which is really annoying if you're off campus because then you have to use the VPN. There's instructions how to use the VPN on this site, but it's not fun. So not the worst thing, but it's a little annoying. Yeah, I recommend using Vim Tutor to learn how to use Vim. It's kind of cool. Yeah, some references, and I guess the last thing to mention, and then we'll be done with this first lecture, is AI, my AI policy. I don't use AI at all. I just don't use it at all. I really like coding. I really like programming. I like the challenge of learning how to do things myself, so I don't use AI. But that being said, I can't. There's no way for me to enforce for you not to use AI. There's no way for me to prevent you from using AI for the projects and exercises and homework assignments. So you are allowed to use it for those projects. For those assignments, I strongly discourage it. I encourage you to, I guess for lack of a better word, struggle against the homework, project, and exercises yourself, because that way you'll really learn what's going on. And of course, the use of AI or any other digital tool during the midterm and final exams is strictly prohibited. Do not do that. You'll get a 0 on the exam and perhaps worse. But again, for the projects, homeworks, exercises, I discourage it, but I can't prevent it, so do as you will. And also, hopefully I'll, bless you, persuade you by the end of the semester that you don't actually need to use, not let alone AI, Google even, when working with many of these, when developing system software, because there's a lot of tooling in place that older programmers have set up to be able to quickly get help totally offline when writing this kind of code without having to go to some external assistance. Yeah. Okay, so that wraps up the first part of this lecture. Any questions before I continue?
You said we're going to use Git to turn in our homework, but web courses to turn in project submissions?
Homework submission. Sorry, again, I misspoke. Yeah, so web courses for homework assignments, Git for exercises and projects. And the web courses for midterms and finals as well. Yes?
For the lab sections, if we're unable to go to our assigned section, is it fine if we go to another section?
Yeah, I'm fine with it. I don't care. The lab's attendance is ungraded anyway, so it's not like anyone's actually going to check that you go. I recommend going. But yeah, you can go to whatever section that is easiest for you. I don't regret it at all. Sorry, been a little sick these past few days. Do we want to take a break, maybe for 5 minutes before we continue? Do we care? I know it's kind of a long lecture. So I see a few people getting up, so I'll wait till 5 o'clock before I continue. Actually, what I'll do now is export this. Okay, then I'll delete that, so it's ready for the next lecture. I guess quick poll. Raise your hand if you use VS Code. Yeah. Raise your hand if you use Copilot while you're programming. Yeah. If you don't use VS Code, can I ask, is anyone willing to share what they use instead? I know you had said C-Line.
Visual Studio is one too.
Okay, just Visual Studio. Okay.
I use code blocks.
Oh, code blocks? Okay.
Using Spider.
Spider. I think I've heard of that one a long time ago. What is that?
I think it's mainly for Python, but you can do it.
Oh, so it's Spider. Okay, I get it. Yeah.
I've been using Nano.
Nano. Okay. Nano's nice because it's so lightweight, very quick to install. But I don't know. Can you install plugins for Nano? Do you know?
I don't know.
No.
Are test days the only 2 days where we're going to need to have a computer in class? But it's a good idea to have.
Yeah, the only 2 days where it's required. You probably want to bring one for the other days so you can follow along with what I'm doing. Though sometimes I'll be writing code pretty fast and you may not be able to follow along, but if you want to, then yeah, you can bring a computer to kind of follow along. I guess another poll, raise your hand if you use Windows and Mac and Linux. Yeah. It's just easier to use the command line when you're on Linux or Mac.
I switch between them. I have a Google Drive for Linux and Windows. So
Okay.
I can do either.
Yeah, dual boot. Yeah.
I recently found out about WSL and it's
Yep, the whistle.
so good.
It's pretty useful. I use that in undergrad. Actually, when I was taking this course, I used the whistle, WSL. I used that for the compiler project. I would always log into that. I would, go into that, and then I would do all my compiler code writing in there.
Yeah.
Yeah.
Like last semester when I started downloading the weird GCC from sketchy website,
Okay.
or what it looked like a sketchy website, but you just install it on yourself.
Yeah, you mean MinGW, the one for Windows?
Yeah.
Yeah, that one that's kind of a pain to set up. Yeah. Yeah.
When dealing with Eustace, do you personally find like using MOBA extern or just?
Oh, don't use MOBA extern. Don't use MOBA extern. You have to use SSH. You have to log in via the command line. You can't use MOBA extern this semester. Thanks for bringing that up. I almost forgot. Don't use MOBA extern. Yeah. Yeah.
Did something happen with that, or just?
No, just the whole point is to learn how to use the command line.
Oh.
That's another reason why we encourage you not to use an editor like, I don't want to pick on you, but like code blocks, because that kind of abstracts and hides some of the details of how the whole compiler toolchain works. So the whole point of this course is to teach you how to use your tools, master your tools, manipulate your tools, and in the spirit of that, we do everything from the command line so that you learn at a pretty low level how everything works. In the future, you can stop using the command line if you don't want to, and you can stop using any kind of editor like Vim or Emacs whenever if you decide to try this course. I just would hope that you all can at least try these things or expose to them so that in the future you can learn what the fundamentals are and also eventually learn the value of mastering your tools, whatever they are. I got really good at VS Code when I was an undergrad. I used it for like 4 years. I learned all the hotkeys, all the shortcuts. But there was eventually I reached a limit with what I could do with it, and now I'm preferring to learn Vim because I feel like the skill cap is higher there and there's more opportunity for growth, for me anyway. I don't know, your mileage may vary. Okay, so it's 5:01. I think everyone has come back in by now, so I think we can start the next lecture on the command line. So getting started, we're going to use SSH, secure shell. So I have my command line open here. I'll open the Windows or the internet browser on the left-hand side. And I really wish this standing desk would raise so I could actually type more comfortably, but oh well. So we're going to use SSH to log into the Eustace server. Who here has used Eustace before? Who here has used SSH from the command line to log into it before? Okay, that's good. So many of you have probably logged in like this, where you type in your full NID, cs.eustace. I think that's the correct, no, is it 3 E's? What do I have wrong? Is there something wrong here?
Too many E's.
Is it, it's 2 E's and then what's the end here? Eustace dot, what?
Or Eustace.ees.
Eustace dot EECS? Like this? Dot UCF.edu? Oh, here we go. Cool. So you can see I was prompted to enter my password for my machine, not on Eustace, because I have a password manager set up to automatically log in for me. What this also means is that instead of logging in with that whole command line here, this whole invocation that you can see I clearly forgot, I can just type SSH Eustace and that logs in for me right away. I have a whole configuration set up in my .ssh directory for doing this. We have instructions on how to do this or links to instructions on how to do that yourself in the course notes. I recommend setting it up because it's a pain to have to type all this stuff out to log into Eustace every single time. So, yeah. So we're in Eustace. We're at the command prompt. So I have a terminal window open here. The terminal emulator I use is called Kitty. That's like the kind of terminal emulator I use. If you're on Linux, the default is the GNOME terminal. So the window itself is the terminal emulator. It is emulating like an actual computer monitor with a keyboard attached to it, which people had in the old days for interacting with computers. In the terminal, we are on the command line where we're entering commands. So I can enter, well, I'm not entering commands yet, but I can enter commands, and these commands are being sent or processed by Bash, the born-again shell. It's a programming language. So I've kind of thrown 3 different terms at you here: the terminal, the command line, and the shell. So we're on the window itself is the terminal. The command line is where we're typing our commands. and bash is the programming language that is interpreting all of our commands and running them. So right now, bash is waiting for us to enter a command. So the command we'll run first is ls. So does anyone know what ls stands for? List, right? So ls lists the contents of your current directory. So we can pass flags to commands to modify their behavior. The way we would do this, for instance, if I wanted to list, so I can do ls to list the contents of my current directory. If I do ls-l, pass the -l flag, it lists the contents in a more list-like fashion where they're listed in a row consecutively one at a time. There's also, -a to list everything, even hidden files. You can see there's some files that start with a dot here in my current directory. These are hidden files by default. They're not shown by ls with a normal call of the command. You have to pass the -a for all flag, for the all flag. Now, if you want to learn more about a command, you can type man. This is the manual command, followed by the name of the command that you want help with. We'll be seeing a lot more about man later this semester. So if I type in man ls, you'll see that I have the man pages open, manual pages, often called man pages open, open for ls. It tells you a description of what it does, a synopsis on how to use it. These brackets denote optional arguments, and the ... mean at least 0 or more. And there's all these different options here. Also worth noting here, the see also list is often useful for seeing like other commands that are related to the one you're getting help with. So yeah, 2 basic commands, ls and man. Man is going to be very useful for you throughout this entire course, and we're going to see ways to call man without actually running the man command via the command line. Yeah.
What keys are you inputting to clone your last entered command or to reset the...
Yeah, that's the next couple of slides, so I'm glad you asked that. Yeah. No, that's good. It's good that you are asking those questions. So to clear your screen, let's say I type in ls, I can press Control-L. Now, Control-L, it clears the screen but does not clear the, buffer of what's been printed. So I can actually scroll up, or I should be able to here. ls, and then Control-L, maybe not here. Maybe if I go to my local window. Well, I think maybe because of the terminal I'm using, the emulator I'm using, it doesn't show it. But normally in your terminal window, you'll see that if you press Control-L, you can scroll up and actually see the previous commands you entered in their output. It's not totally gone. You can still see it. Now, the alternative is running Control-Alt-L, pressing Control-Alt-L, and this totally clears everything. Your output will be gone from the buffer entirely. So you can't scroll up and find what you've typed before. It's totally gone. I recommend learning these hotkeys really well. What I've actually done is set up an alias to where if I'll explain that later. Another way to clear the screen is to actually use the clear command directly. So this is another command. Oh, you can see it's actually here. So I've set up an alias for me to force me to learn muscle memory to not use the clear command. So instead of spamming it, I actually have to press Control-Alt-L to clear my screen. So for you, though, you don't have that alias set up. You can just type in clear and clear your screen that way. And that'll clear everything, including anything that's been buffered before. I recommend doing this semi-frequently to keep your screen clear so you're not trying to parse a whole deluge of information every time you want to try to run something or read what's on your terminal window. So there are ways to add comments to your bash commands. So again, we're in bash. We're typing commands to bash. If I type in ls, it runs, but if I type in #ls, it does nothing. Anything that begins with a hashtag is a comment and has no effect. So useful shortcut to know is Alt-Shift-3. Does anyone know what the 3 button turns into if you hold Shift? If you hold Shift and press 3, what number is what character is typed? Hashtag. And we just saw that hashtag was the comment character. So if I press Alt-Shift-3, the current command immediately becomes commented out and entered to the command line. This is useful because then it gets put into my history, which I can navigate by pressing the up arrow. or Control P, and I can go back to modifying that command. So if I have a command that I'm typing out that I haven't finished yet, I don't know exactly what I want to write, I can just type Alt-Shift-3, it does it again, and it will immediately comment it out, then I can go back later and finish writing that command if I want to. A quick and dirty way of just saving commands that you didn't quite finish. So for the file system hierarchy, we're going to start looking at this now. So I am in Bash, there is a special variable that stores the current working directory. It's internal to Bash, where you are situated on the command line. Any file names you type in or paths to different files, and we'll talk more about paths soon, are all going to be relative to your current working directory. So here, my current working directory is this tilde, which is short for my home directory. And you can see these files, these directories are my current directory. We can move around the directory hierarchy. Let me actually try this here. I'll go to the root directory. So the slash here is the root to my file system. So on Windows, you might be familiar with having a C drive, a D drive, an E drive, different drives, and each drive has its own file system inside of it. On Linux, there is just one file system, and everything else is really a node, or a leaf perhaps, of that file system. So to illustrate this, let me change my tab here. If we are at the root directory, which again is a slash, this is the root of the file system, from which everything else stems from, then there are going to be other directories underneath this. If I type ls, you can see there's a bunch of different directories here. So the things in dark blue are directories themselves. And I keep saying directories, maybe I should clarify what I mean by that. I mean a folder. On Windows, the official name is folder. On Linux, they use the name directory. So, for instance here, there's this user directory. So I'll type that out here as well. User. And it's often a convention, you'll see people add a slash to the end of a directory name to quickly identify that as a directory rather than a regular file. And I can actually use the cd command to cd into change my directory, that's what cd stands for, change my current working directory to be the user directory. And that's where I am now. So you can think of this, if we're going to illustrate this, I'll just draw it with the pencil tool here. We have ls branching off, maybe I'll make that a little bit thinner. ls branching off into the user directory. And in the user directory, we have more directories. So we can cd into, for instance, the bin directory. You can see there's a whole bunch of files in this bin directory. So I could actually draw another line here. This is the bin directory. Now, there are some other files that each directory has that are special files. For instance, if I go back to the root directory here, you can see we have all these different files, but if I pass the -a flag to ls, so I mentioned that earlier, a for all, you'll see two new additions to our output. This dot directory and this dot dot directory. Does anyone know what the dot directory is? Has anyone seen this before? Yeah?
Current?
It's the current directory, yeah. Not the current working directory, but the one that you're referring to. It's relative from. So for instance, let me draw this out here. This is the dot directory. And if I were to cd into the dot directory, I would stay at the root directory. If I go into the user directory and then cd into the dot directory, I stay in the user directory. Dot just means the current directory. The reason we need this directory is so that we can run commands that we make ourselves. With /main, for instance, is how you would run a binary called main that's in your current directory. You need to specify the path to it. You can't just type in the name, you have to specify a path. This is for security reasons. So that's why there is a dot directory, even though it seems redundant. So each of these directories that we've just seen have their own dot directory. Let me drag this here. and I'll draw some more arrows just to signify, just to signify this. Now, there's another directory that's special, this ... directory. And what this one refers to is the parent of the current directory. So I'll draw that here, here as well. Maybe I'll draw it at an angle so it's better. And each directory has a ... directory inside it. It's a special directory. And I'll change my color now to be orange, so it's different. And the ... directory always refers to the parent. So if I were from within the user directory, if I do cd ... where do you think my current working directory will become? The root. So now I'm in the root directory. Now for an exception to this rule, if I do cd ... from within the root directory, I just go back to the root. So just to illustrate this, sort of the paths that we're following here. And the ... directory would go back to user, ... would go to slash, then we'll go back to here, and ... will go back to user. So I know it's a little messy. I'll clean it up before I post it online. But have any questions so far about this directory structure that we're going over, this file tree that we are sort of seeing established? Yeah? The dot is referring to the current directory. So to illustrate this, I'll do a few examples just to show you. If I change into the current directory, if I change my directory into dot, and I'm in the root, I stay in the root. You can see what directory I'm currently at with this these green characters here. If I go into the bin directory, or sorry, the user directory, and I change into the dot directory, I stay in the user directory. If I change into the bin directory now, and I cd into the dot directory, I again stay in user bin. So it's always the current directory. Any other questions? Yeah.
We use that because we're probably going to be doing operations later in conjunction with the dot, right?
Yeah, you'll be calling a binary you've compiled yourself, and you need to use the dot to tell bash that you're trying to run a binary that is in the current directory, rather than one. I'm going to explain shortly why you need to make that distinction. Okay, so I'm going to continue before taking any more questions. So yeah, root directories is /. We separate directories with more slashes. The dot is a current directory. ... is the parent. Oh yeah, and there's also the home directory. So if I type in cd tilde, I go into this special directory here. Where is this? Well, we can use the command pwd to print the working directory. You can print the current working directory. We see that I'm actually in home net brz br whatever, my NID. That's where I am right now. You can also access this by printing a special bash variable. So again, we're in bash. Bash is a programming language. It has variables. Some of these variables are set up automatically for you by the shell, by bash. One of them is the home variable, which just expands to the actual home directory. There's some subtle differences between tilde and home. If you're on the shell, you can use tilde. If you're in any other application, you might want to use the home variable. I won't go into the big differences here, but bottom line is that for our purposes, they're basically identical. So tilde is just a shorthand for your home directory, which in my case is here. Yeah?
Is home case sensitive?
Yes. Yes. Bash, the automatic variables bash creates for you are all capitals. Yeah. Yeah, so we saw the example. So there's a difference here between, let me see if there's anything else here I should go over first. Yeah. So we talked about paths a little bit, kind of danced around this idea, but as we add slashes to these different file name. So if I go back into slash here, user, bin, this is what's known as a path. So a path tells you where a file is on your system, on your file system. If a path begins with a forward slash, it is an absolute path. It is absolute from the root. It tells you the entire path to the file you're wanting to know where it is. If the path begins with anything other than the slash, so for example, ... slash, this is a relative path. It's relative to the current working directory. So for example, if I type in cd slash home, so cd ... slash home net ... slash slash, let's do one more, bin, or no, include, maybe? Yeah, media. What happens here is that this would be the parent directory, clear the screen, going up into the root, so we're starting in the user directory, we cd up one into the root directory, we go into the home net subdirectory, we go back up out of the net directory, back up out of the home directory, and then we go into the media directory from the root. That's where we would be here after running all those commands. I'm going to ask you a few questions this semester, not a lot, because I know this stuff is like kind of annoying to parse through all this different path stuff, where I'm going to give you a current working directory and a bunch of different paths, some relative, some absolute, and ask you to create a file tree that matches the different paths that I've given you. And if you want to be able to see the tree, an example of a file tree, I'll just show you one now. Let's go to the directory for last course, or last semester. I can run the tree command on a directory to see the contents of that directory in a tree-like structure. So this is not a standard Linux command. It doesn't come with every Linux installation, but you can install it pretty easily. And it shows you just like the contents of a directory hierarchy in a tree-like structure on the command line. So it's a good one to know just for like getting a grasp of where you are. If you don't pass any argument to the tree command, then it just assumes you want to look at the current directory. These are all the contents of my current directory. I'm running this from here, not from the root, because if I were to try to run the tree command from the root, I would get a whole bunch of like output that I couldn't even parse. So yeah. So much for paths, absolute versus relative paths. Any questions about absolute versus relative paths? Yeah.
With the relative path and absolute, are you referring to when you use ... or when you just type out the name?
So if it begins with a slash, it's an absolute path. Anything else, if it begins with anything else, it's a relative path. So cd ... slash home, that's a relative path. cd ... slash, that's a relative path. cd slash user bin, that's an absolute path. So now, I think, let me see what else is next here. Okay. So navigating the file system, we kind of went over this already. I showed you how to use, we've seen PWD, we've seen ls, we've seen cd to change the working directory, using cd to navigate the file system, move around. And one thing I want to make clear is that these commands, ls, pwd, cd, these are, well, some of them, they are actually programs written by somebody else. So if I do man ls again, you can see at the bottom, it says copyright and author, Richard Stallman and David McKenzie. Richard Stallman's like a very famous programmer as well. The reason that Bash is able to find this binary and know where to run it from is because it is part of the path environment variable. So again, the shell has variables. One of them is the path. So I'll look at this out here. The way the path variable works is that when you go to run a command that has no dot in front of it, it's not a path, it's just a name. If you type in a command name and then press enter, bash will actually look in all of these directories, which are separated by colons, for a program whose name matches the name of the command you're trying to run. So if I try to run ls, bash is going to look in all these directories for a program named ls, and if it finds one, it's going to run it and stop looking for other programs. And I can prove to you that this is the case because if I go into the user bin directory and ls its contents, if I scroll up here, you can actually see in this directory, there should be one somewhere here. There's a faster way to do this, but I'm going to try and do it. I'm going to scroll and show you. So LMNOP. Well, I can't even see it. Okay. Well, you can actually pass a path to ls, and it will print out that file name if the path exists. So you can see ls actually exists in my user bin directory, which again is on my path. User bin, which local user bin is right here. It's on my path. So that's how bash knows where to call the ls binary from. Yeah.
Is there a way to open ls to see what's inside?
Yeah, I mean it's a binary. It's compiled already. It's machine code.
Oh, no.
So you can do that, but the source code is also publicly available. Richard Stallman, the author, like GNU, he believes vehemently in open source software. So you can find the source code for ls online. I think it's written in C. You can just find it online if you want to read it. I recommend reading it. I recommend reading source code like you would read a book or a textbook because that's how you can learn how to better write code yourself if you just read other people's code online. It's a great way to learn. Okay, so this is why we have to use / to run our own programs like main. If we compile a binary to a program called main, we have to use / because otherwise the shell is going to try and look through the path for a name of a program with that name. Okay, so one distinction I want to make here is that there's a difference between commands, or commands that are programs, and commands that are shell built-ins. So if I try to run man to get help for the cd command, you'll see we get no manual entry for cd. The reason for this is because cd is not a program. cd is actually some built-in functionality to the shell. The reason for this is because it has to be, since the current working directory is like an internal special variable to the shell, it has to be a shell built-in that changes the current working directory. So to get information about a shell built-in, we have to use the help command. So if I type in help cd, you can see this whole help page is printed out for the cd command. So I'm just making this distinction clear because I know when I started programming, people only told me about man. And then when I went to get help about certain commands, nothing popped up. And I thought, what's going on? Nobody told me about this. This doesn't work. There is a difference. There's programs and there are built-ins. And the way you can check if something is a built-in or a command is to use the type built-in and then pass the name of what you want to check to it. Sorry, type cd. And it will tell you it's a shell built-in. Now, for some commands, they exist as both a built-in and a binary. This is for compatibility reasons in case the shell you're using, which may not be bash, doesn't have that functionality implemented. So for instance, echo, which we'll see later, if I type in type for echo, you can see it's a shell built-in, but if I pass the -a flag for all, so this type command or built-in also has an a flag, which also happens the same for all. That's kind of a convention in these shell commands. You'll see that it has multiple variations. So the first one is a shell built-in. The rest are binaries at these locations. By default, bash will use the first one in the list. So I'm just drilling this point home. I know it seems kind of trivial, but it's very helpful when you're trying to get help for a command and you want to know whether or not it's a built-in or a program. Okay, any questions? Hopefully that's not too much minutia and detail. Okay. And there are ways to override what bash defaults to. You can tell bash to use the command instead. So I could say command echo, and then bash will actually default to using the program version of echo rather than the built-in. And I can say built-in Echo, and Bash will use the built-in version of Echo rather than the program version. But you don't really need to know that for this course, just some extra information. Okay, now take one break to have some water, and then I'm going to move on to how to actually accelerate your command line usage. Okay, so far, if you only use the skills that I've shown you so far, you'd be a pretty slow programmer, and not like in a good tortoise way, but just like slow, ineffective way. Probably the biggest win you can get out of using the command line is to use tab completion. Please use tab completion. Do not like come into my office hours and type out commands and path names without any help of tab completion. It's painful for me to watch and painful for you to use. So when I'm typing in a name of a file that I want to change my directory into, for instance, I can press tab, and if there's only one entry there, it will automatically complete. If there's more than one, I can press tab twice, and all these different options will show up for me. Now, if I type in the name of a directory here, I'll say, let's say the user directory. Because there's only one directory here that starts with U underneath the root directory, if I press tab now, it automatically completes to the user directory for me. I can press tab twice again here and see if there's more. There's bin. I can type in G for games, and immediately it completes for the games directory. This is also not just a way to quickly navigate the command line, but a way to quickly check if a file that you think exists actually does exist. Because if it doesn't, then tab autocomplete will just not work. This is what I meant earlier when I said programs will seem to even anticipate your needs. This is an example of that. And there are actually ways, if you really want to learn them, to modify Bash to have your own custom tab completions for your own programs that you write. I won't go into that in this course, but it's kind of cool to be able to do that. Yeah?
Is it hard to set it up so that it'll show you in like highlighted characters, whatever, what would happen if you press tab given whatever you've entered? Like if you type U, it'll fill in the SR to show you that the next thing that would happen if you press tab is user?
I don't think it's that hard to set up. I know some shells I think actually do that, but I think some shells actually do that. I just don't have that set up for myself. Yeah, I think you can get that set up though with certain shells, or terminal emulators might do that for you. I'm not sure. Yeah, so the virtue being shown here is impatience. And also laziness. Don't remember the names of files entirely, just let the shell remember it for you. It's going to be really hard to memorize all these file names as you program a lot in the shell. Just remember like a prefix, first two characters, whatever, press tab, look at the whole name, and then figure it out from there. Yeah. Let's see. So I showed this before, multiple conventions, multiple completions if there's multiple matches. And what's actually kind of cool with this is that if I go into my user include directory, if I ls the contents here, you can see a bunch of .h files. These are header files for programs installed on this machine that my C programs can actually call. If I type lsgn and press tab, you'll see it auto-completes GNU, but if I press tab again, you'll see there's more things that have GNU in the name. So autocomplete will actually autocomplete the greatest common prefix amongst all the possible matches in that directory as well, which is also really useful. Okay, just hit tab, spam tab. Just press it a bunch of times. Get used to using tab. You'll greatly accelerate yourself on the command line if you use tab. Okay, so we're kind of running low on time, so I'm going to go over some useful shortcuts here. Yeah, okay. So if you're typing a long command, I'm going to go back to my home directory here. And if I start typing a longish command, let's say I want to ls the user directory and the home directory. You can pass multiple directories to ls and we'll list the contents of both of them. Let's say I type that out. I can press Control A to go to the beginning of the line, or the home key, but Control A is better because you don't have to leave the home row. Your fingers can stay in the home row, so it's a bit faster. You don't have to reach all the way across to the home key. The mnemonic is A for beginning of the alphabet A. It's the beginning of the alphabet, so go to the beginning of the line. Control E for end goes to the end of the line. Again, you can press the end key, but who wants to reach that far? You can just hold Control and press E. Backspace deletes the character behind you. That's pretty obvious, I think. You can also press Control H to delete characters too, though. Again, don't leave the home row. Alt backspace goes back a word. You can see how I go back like different words here. That's pretty useful. See if I can zoom out a bit more. Okay. Yeah. Alt B also goes back a word. Oops, I didn't mean to do that. Okay. Alt B also goes back a word, so B for back. Alt F goes forward a word. Again, the benefit here is that you're not leaving the home row. You're going, your fingers are staying in the home row, so it should be faster to type Alt F, Alt B. And these shortcuts are essentially going to be, you're going to have to use muscle memory to remember them. So just like if you've ever done, I don't know, martial arts or drawing or any other kind of skill that involves, I guess, motor function in some way, you have to drill these things and practice them until eventually you remember them. The mnemonics help though. So other commands for modifying text, I guess, yeah, if I have like this random string here, Control D, delete a character in front, Control B, move back, Control F. Notice that Alt B and Alt F go forward, backwards and forwards a word, respectively, but Control B and Control F go backwards and forwards a character. So there is a difference. Alt D deletes in front. I don't use all of these shortcuts all the time. Trying to get better at it. The one that I really use a lot is Control K and Control U. So if I type in, again, ls, /user, and type in Control K, that will delete the rest of the line. I can also press Control U, not listed here, to delete what's before me on the line. The biggest reason, Control U is very useful because if you're going to type in your password, you'll notice that we have to often type in our passwords in the command line when SSHing into Eustace, for instance. And you'll also notice that when you do that, you don't see your password printed to the screen. This is for security reasons so that someone behind you cannot just read over your shoulder and read your password. But if you made a typo and want to be sure that your password is totally erased, just press Control U to erase everything you've typed so far, and then you can start typing from there. So it's useful to use Control U to just clear the current line. Yeah. So again, if I have like ABC here, D, E, F, G, Control U clears everything before, Control K clears everything after. And like that, the whole line is clear. You can also just press Control C to cancel whatever you've typed so far. Yeah, Control Y for yank, so Control Y. Well, what that does is if I delete something from the shell, I can press Control Y to paste what I just deleted. This kind of comes from Vim. We'll see more of this later. The history is also really useful. So you'll notice that I've been, oops, let me reopen that. You'll notice that I have been pressing or quickly going back to commands that I've previously typed. Let's see right here. So if I type in ls, I can press up arrow, oops, there we go, the up arrow to go back to the command that I just ran. And I can keep pressing the up arrow to keep going back. But again, instead of reaching for the arrow keys, which are sometimes small and far away on your keyboard, you can also press Control P to go to the previous command, and Control N to go to the next command. You can always check your history by using the history built-in, which will list all the commands you previously typed. I've modified my history to record like a long list of commands. You can change the max size of how many commands are recorded. You can also record the date in which you ran each command. I record the whole date and time. I want to have a complete record of what all the commands I ran and when. It's useful for my research sometimes to remember this stuff. You can also clear your history. There's, if I type in help history, you can see all the different options. So I recommend familiarizing yourself with the history a little bit. Now, one of the most useful things to do with history is use Control R. This is a reverse lookup. So if I press Control R and type in ls, and then keep pressing Control R, it will keep going through all my previous commands that have ls in them. You can see at the very start of this lecture when I showed you that trick with the Alt-Shift-3. Now if I press Enter, or Enter, it will immediately run whatever is currently shown on the command line. So be careful, because you might accidentally run a command you didn't mean to run. So it doesn't put you into editing it, it immediately runs that command. So get familiar with Control R as well for reverse searching commands. It's really helpful. So that's useful as well. Commenting out commands for saving them for later. Okay, some other basic command line commands. If you want to view the contents of a file, so I'll go to the my home directory here. I guess first let's create a file. So I'm gonna, let's see here. Actually, So if I type in cat and then pass readme.org to cat, does anyone know what concatenate stands? Or I already just said it. Cat is short for concatenate. You can type in cat in the name of a file, and it'll print out the contents of that file. You can pass cat multiple files. I could say hellograder.sh, and it will print out both the files in sequence concatenated together, essentially. This isn't like giving away anything for the course grading. There's no solutions here. It's just the grading script that we use. If you want to view the contents of a file, you can use more. This shows you the contents of the file in a paginated fashion, so you can scroll down and view more of the file. But more is kind of annoying because you can't scroll up. What's even better than more is less. So it's kind of a joke. And with less, you can actually use the up and down arrows, or J and K, which I prefer because that's the Vim key bindings for up and down, or down and up, I should say. You can actually scroll through the contents of a file this way. So recommend learning less. All right. Let's see. So if I want to edit a file in Vim, let's say I want to create a file here. I'll create a file main.c. Oops, I actually had that key binding set up that I had forgotten about. Go back to my home here now, my local machine instead. What? Oh, I maybe there's a question. Okay, so I'll type in a file here. If I want to save this file, I can press Control-Z, or if I want to stop editing this file but not close Vim, I can press Control-Z to suspend it, and then FG to bring it to the foreground and resume editing it later. We're going to go over this more later in a future lecture about suspending processes and resuming them. But why this is useful is because it lets you basically have this workflow set up where you are editing your file, and then you can press FG to go back to where you were in editing and see my cursor is still at the same spot as it was when I exited. So it's not like I have to reopen the file and then navigate down to the exact line I was previously on. I can just go here, press Control-Z, and then FG and go back to where I was and keep working from there. So this is kind of useful if you're editing on the command line a lot. You can also suspend long-running jobs this way as well. So if I were typing ls or find, this is going to be a long-running command. Or tree, I guess. Tree in the home in this directory here. Remember that takes a long time. The tree command prints everything in a tree fashion. I can press Control-Z to stop it, and then FG to resume it later if I wanted to. You can always press Control-C to cancel a job that's running, cancel a command while it's running, and stop it. All right, let's see. Okay. I think we have time for the last few things here. So one useful command is wget. Wget lets you, it's like webgit, it lets you download a file from the internet. So many times in this course, we're actually going to give you a link to some files we need to download with wget, and then use that as some starting code for a project. So for instance here, I'm going to download, see if I can zoom out here so I can copy the whole link. For homework 2, you're going to have to copy or download a file at this link. So if I run it here, you can see it actually downloaded the file. It said it was okay. And there's this file here, homework2.tar. And I can actually extract this file with the tar command, passing the X for extract, V for verbose, and F for file name, homework2.tar. You can see it extracted this file, so it was a compressed file. It extracted it all like a zip file, but decompressed now. You can see that homework2 directory is now here. I can cd into there, and there's all these different directories within it, and you'll have to manipulate this directory tree for the homework2 using these commands. So these are the last commands I'm going to go over. Yeah, today, and then we can wrap up. So the first one is touch. Touch lets you create a file with no contents. So I can say touch foo.txt, and now foo.txt exists. RM lets you remove a file. So I can remove foo.txt, and it removes that file. If I try to remove a directory with RM, it gives me an error, cannot remove homework2, it is a directory. To remove a directory with RM, you have to specify the force and recursive flags. The order can be different. You can use RF if you like. I like using FR because it's like for real. Remove for real. So force recursive, it removes files whether or not they exist, which is useful later. We'll see why that's useful. And R means recursive, as in you're removing a directory and everything within it, like that. And now homework2, oops, is gone. If I want to move a file, I can move, for instance, let's touch a file, I'll make a directory. So make dir lets you make a directory. I can create a directory foo, and then I'll create a file here, bar.txt. I can move bar.txt into the foo directory like so. Name of the file I want to move, and the destination is the second argument. And now, if I ls the foo directory, or if I run the tree command here, you can see that bar is within the foo directory. I can create a whole bunch of directories at once with the -p flag, which says create parent directories along the way and don't throw an error if a directory in the path doesn't already exist. So I can say fizz, buzz, baz, and then if I run tree, you can see all three of those directories were created in that whole tree. So the -p for parents flag is sometimes useful with make dir as well. There's also move also lets you rename a file. So if I go into the foo directory here and have the bar.txt file here, I can use move to rename this file into, I don't know, baz.txt. And now it's been renamed. So there's no rename command in Linux. You have to use move to move a file to a different name. That's sort of like a just idiosyncrasy of the show. We can also copy files. So cp for copy, baz.txt to bar.txt, and now both files exist. And if I remove all these files, both these files with bar and baz, remove them both, then I can use the rmdir command to remove an empty directory. So rmdir only removes empty directories, and you can see now it is gone. So the way this actually works, rm for real or rm force recursive, it actually is a post-order traversal. So again, like an algorithm you probably learned in CS1 or CS2 perhaps, or I think you've taken CS1 at this point, not CS2. It will actually go into directories, remove the individual regular files in them, and then go back up to the parent directory and remove that directory using rmdir. So that's how remove actually works under the hood. Okay, and very last one I want to show, which is a really useful command. We are just almost out of time. Yeah, very last command I want to show, which is sometimes very useful, is the fc command. This will open the most recently entered command in your editor. So my editor is Vim. You can configure this by setting this editor variable here. And now I can change this as I see fit. I can change it to pwd for instance. And if I save and close this file, so in Vim you do that with right quit, wq, then it actually will run that command for me. So it's kind of useful to use that fc command to change a command with all the features of your editor, and then you can save it and then immediately run whatever you were trying to type out. Okay, and that's it. So I'm going to wrap up the lecture now. I'm going to save the recording here.